Hello. This is Modeling Learning Assignment 3. Today we're going to be building a very simple shelf. Now this is going to be a shelf assembly, so let's get started. First we're going to have to make all the parts for our assembly. And all an assembly is it's a collection of parts where you space the parts and you orient the parts and you connect the parts in very specific ways. So we're just going to do a very simple assembly here. You can always get more complex, and then we'll take that, and as we have done in our previous drawings, we're going to take those and put them into a drawing to present as a total file. So just a little bit of a different type of experience here in SolidWorks, a little bit more complex than what we've been dealing with. Now, to start, we're gonna have to create a part. So here, what I'm gonna do is I'm gonna build a shelf. I'm gonna build the top of the shelf. I'm gonna build the two brackets. I'm gonna build a spot in the back. And lastly, I'm going to make a screw that I will use to connect all of them together. So pretty simple again. The idea is that I would make all of this out of wood. So we'll start with a sketch. Here, I'm going to draw the top on the top plane to represent the top board. Here, I'm just going to give a rectangle. Now, you could do one corner from the origin. That's one way of doing it. That's probably the best way of doing it. So I'll just draw a rectangle like this. Now, I'm going to make this rectangle be, let's see, usually shelves are 10 inches deep, so this will be 36 inches wide and 10 inches deep. And there's my shelf top. Now, I could go in here and around the edges, but I'm going to try to make this a faster video. You'll notice it's fully defined, just with my 2 dimensions and putting the corner right there at the origin. I'm going to extrude this. And this is going to be my top board. So it'll be about 3/4 of an inch thick or so. We'll just make it 3/4 of an inch thick. 0.75 inches. We'll do a blind extrusion and enter. Call it a day. Now you can set this material to wood. There's a number of ways of doing that. Here, if you select material wood, they'll have some implications on material properties. Otherwise, you can actually change the appearance and make it look like wood. I don't care about appearance because I'm not an artist. So I will just go in here to save as. I'll navigate to my modeling learning assignments folder. Right now I'm in a vacuum folder. I'll go in here, and then what I will name this as is MLA 3 top shelf. Now, oftentimes naming schemes for assembly items can actually get a little bit more intense than that. Here, I will actually list out the dimensions of the part so that it's a little bit easier to identify. So this is going to be a 36 by 10 by 3/4 inch, 0.75 in wood plank. And that'll be my naming convention that I give this specific piece. So this will say here's what the component name is, and here's the dimensions of it. And I even included the material, which probably isn't necessary. So there's one component. Go ahead and save it. And now I need to make side brackets, so I'll make a new part. Now, in an assembly like this, each part is expected to be a piece that is assembled in. You can technically make parts that get welded in, and then they merge from two different parts into one part. Yes, it gets a little sketchy there, but usually when I think of a part, it is a part that can be removed from a system or must be attached to a system through some kind of removable connection. That's how I see it. So here I'm going to sketch this one on the right plane, because here I'm going to be sketching a bracket. And for my bracket, I can make this as simple or as complex as I want. I'm going to set the origin to be the top back corner of the bracket. And then I'm just going to draw a line here, 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 and then close it off. And you'll notice that it immediately forms a closed space. I'm going to click off of my line, and I'm going to force this line to be horizontal. That one's already set to be vertical. I'm going to click this line, and then I'm going to hold down Control and click this line, which will add the ability to add existing relations. And I will set these two to equal, which is nice. So that I only have to dimension one. And then I will hit OK. I'll select this line and this line down here, again hitting Control and then clicking. So that allows me to select both lines. That'll allow me to make these then equal, just so that it's a little bit more square of a bracket. SolidWorks is going to whine like heck. And then I'll hit OK. Now I'm going to throw in 2 dimensions, because I only need 2 to fully define this. I need to define this one. This is going to be 3/4 of an inch. And you know what? I would like to cut one of these out of, like, I'd have a board running this direction, and I would just cut these brackets out of like a 2x6 or so. So I'm going to set this dimension here. I'm going to say that that's going to be a maximum distance of half of a full 2x6. So here, 2x6 is approximately, oh, stop whining. A 2x6 is approximately 5 1/4 inches. So I'll just set this at 5 1/4 inches. Okay, and this will fully define my system. You'll notice it becomes a lot bigger here. So if I zoom out, that's my bracket. Okay, very simple. I can always set it a different dimension to describe this, but this is going to give me a square bracket that I can cut out of a single 2x6. So I'll hit Exit Sketch, and then I'm just going to extrude this. Again, I'm going to extrude it about, here I'm going to make it out of a 2x6, so I'll make it be 1 1/4 inches thick. 1.25. And I'll hit yes. Now I could again specify the material as wood. I don't care enough, so I'm just going to go ahead and save this one. I'm going to save it in the same folder as I saved this top shelf piece, and it's going to be saved as MLA 3 bracket, and then I'll give some dimensions on it. Here it's a 5.25 by 0.75 by 0.7. Well, I guess it's not. 0.75 triangular bracket. Okay, and now when I hit save, Oh, it's not a 3/4 of an inch. I gave the wrong dimension on that. Drat. I'm going to close this drawing so that I can go back and rename it. So here, this is to close one specific drawing. You'll notice up here that changes. I'm going to go navigate to that part, change its name. I don't need to open it back up, but I will navigate there and change its name. So all right, so this was the bracket. 1.25. All right, so now the name actually represents the actual item that it is. Now I have one more piece, two more pieces that I have to create. One of them is going to be the back panel. I'll create a part. This back panel, all it's going to do is just be a support for the two brackets. I'll probably make this out of some kind of plywood or board or something, depending on what it looks like. And so here for a sketch, I'm going to do this one on the front plane. And I'm doing all of this on purpose. Front plane because I'm going to extrude backward. Right plane because I want it to be oriented to the right. The top plane, it's going to be oriented to the top. So here again, I'll draw a rectangle from the origin. I'll give 2 dimensions. This back panel is going to be, I'll set it at a distance of 20 inches. Mm, 23 inches actually. I'm going to set it at 23 inches. My reason for that is because I would want this back panel to basically sit between 2 studs on a wall. And if the studs are 24 inches wide, then that's this case. If the studs are 16 inches wide, you know what? We'll go for a 16-inch wall. I'm going to make this 15 inches wide. And then we'll put it right in the middle of that block. Now, our other bracket was only like 5.25 inches. We'll make this one also just be, well, we can set it to 6 because it is a little longer. But then I will exit sketch and extrude this 3/4 of an inch. So this will be a 15 by 6 by 3/4 inch back panel. All right. So usually when you come up with an assembly, if you know where the connection spots are going to be, you can always design them into the parts beforehand. As a part of the design process, what I want to show you here is if you don't know where the connection spots are going to be, how will you connect them? So what I'm actually going to do is I'm going to go ahead and save all these parts and start building an assembly and then design in my connections later. And I'll show you what I mean by that. So here this will be MLA 3. This is going to be back panel. And that's going to be a 15 by 6 by 0.75 inch wood plank. Because that's pretty much what it is. Hit save. And then we have one last part to make, and that is the bolt that's going to be connecting it, or the screw that will be connecting it. So one more part. Go in here. Click part, okay. And we're going to make a very simple looking screw. You can get screw models online, but here we're just going to try drawing a simple screw ourselves, because why not? Now I am going to do this on the front plane, and what I'm going to do is I'm going to revolve a screw, so it'll be a full screw profile. So I will start here in the center with a line. We'll start by drawing the screw cap. And then that will go down about like this. It'll go down a little bit of ways. And then I gotta move my screen down. And then it will end at some kind of a point. And then I'll close it off. So unclick lines. Here I'm going to add some relations. I'm going to make this line vertical. That line's already horizontal. And then I have to add a couple of dimensions. I want this total screw length to be 3 inches. No, we'll do 2-inch screws. 3 inches is a little unnecessary. So these will be 2-inch screws. I want the head of the screw to be, this will be half the dimension because I'm planning on revolving it around. So I want the head of the screw to be, total diameter I want it to be about, we'll say 1/2 inch. So this will be 1/4 inch. Oh. I gotta move some components here. So I clicked out of Smart Dimension. I'm gonna drag this over. I don't know why that's way down there, but I'm gonna move that piece up here too. Alright, there we go. So my screw looks a little less screwy. Go back into Smart Dimensions. I'm going to say this distance here. Typical screw size is maybe 3/16 of an inch, so 3/32 of an inch is a little small, but it'll be 0.09 875. Hit enter. Be kind of a thin screw. We'll dimension this vertical distance here. And I'll just set that at, I don't know, 0.1 inch. Sounds good. And then we'll set this vertical distance here. Come on. There we go. And we'll say that it's got about a 1/4 inch tip on it. There we go. So that'll be our model of a screw. I'll go ahead and hit exit sketch. It's fully defined. Go into features. We'll do a revolved boss base. And hopefully it identifies that I want to do it about axis of revolution. I want it to be here. So there we go. There's our screw. I'll hit yes. Yes, I want it to be 360 degrees blind. And there it is. So there's our screw head. So I'll go ahead and save. I mean, that could also be just a nail. It's a beautiful looking design right there. So this will be MLA 3 screw, and this is a 0.1875 x 2.5 in screw. That's how we designed it. All right, so now we have all of our parts made. Let's go ahead and make an assembly. So here I'm going to open up a brand new assembly. Now we will have to go back and edit some of our pieces to add in the screw holes. We'll do that later. We'll kind of eyeball where they need to be. You can actually edit parts inside of an assembly. Some people find that easier. I hate it personally, but you can inside of an assembly. SolidWorks allows you to do that. So if you want to drill a hole and you don't want to open up the part file, you can do it in the assembly file and it will save to the part. Now here, I want the first piece that you have to pick is you're beginning your assembly. What you're doing is you're basically inserting a component, but when you insert a component, you are putting down what's called a fixed item. Basically, it's everything else is going to be mounted to this piece in the assembly. In any kind of assembly process, you have to have a base piece that everything gets mounted to. You don't just have things just suddenly mount in weird ways. You have to mount them to something. So, whoa, nope, not the back panel. I want the top shelf. My bad. So everything is going to be mounted to the top shelf. Now, when I put this in, I click, puts it down, it centers it, and it immediately brings it up in the part tree over here with an F. F stands for fixed. It means I can't grab this and drag it. It's fixed specifically because it is the part that everything else gets mounted to. So I'm going to rotate to the bottom here. And then I'm going to add in all of my bracket components. So here I'm going to need 2 of the brackets. So I'll put that in twice. Put one over here. Okay. And then I'll do it again. I shouldn't have clicked out of that file because now I have to go browse and find it every time. And then I'll put this one over here. And then I'm going to bring in the back panel. You don't want to bring in too many parts at one time. Here I'm putting in, I have 4 parts. 4 parts is a lot. I'm not going to start bringing in the screws yet. Just because it starts making this really messy. You have to click around pieces, and that kind of becomes a nightmare. So what we'll do, first of all, is I'm going to mate Now, mate is a way of basically forcing components to come together. It's like a relation that we used for parts, except here it's for parts to connect to other parts. So in a relation, it connects lines to other lines, vertices to other vertices, but here this is going to connect parts to parts. So I want the top face here to be on the bottom face of this shelf. So I'm going to reach down here and I'm going to click on this top face, and it will show face 1 at MLA 3 bracket. This part here becomes translucent. The face that I'm selected has become blue. I always going to make sure that this is a face and not an edge that I've selected too. And then I'll click on the bottom face of this panel, and I will make sure that they're coincident. So when I hit yes for that mate, what it means is that this face is now stuck somehow to the bottom of that panel. Which is weird because it looks like it's going through the panel right there. That did not work. I don't know what went wrong there. That is weird. It totally is violating its own mate. I've never seen that happen before. Because they're supposed to be coincident. Alright, there it is. I just had to reorient it. So here, that was weird. SolidWorks would be tripping. I should not be able to pull this down off of that face. Oh, of course, I'm not able to. I just moved it super far away. There we go. So now these two faces are stuck together. I can move this piece, but when I move it, it's going to be moving in one plane such that it never leaves the nice, safe confines of this top board. They're always stuck together. Now, I'm going to have to drill some holes so that I can put my screws in. And these holes are going to allow me to align these components. So that's what I'm going to do right now. So I'm going to go in and I'm going to go back and open my bracket real quick because I closed that file. And then I'm going to go through here and select all of the parts that I'm going to do. So what I will do is I'm going to have my back panel I'm not going to have it be connected per se to my top piece. I'm going to have my top piece screw down into the brackets because I got really thick brackets. And then I will have the brackets themselves screw into the back panel. And that's how I'll do it. So I'll end up with 4 screws on each bracket, and that'll hold everything together. So to do that, I'm going to do a sketch. Now you can go in here and actually do a whole wizard again. We did that on our last modeling learning assignment. You can do that, that's fine. In fact, let's just go ahead and try it. It does a really nice job of showcasing the type of hole that you want to have. Now here, I just want it to be a straight hole. That's called straight tap. Here we're just going to do a standard hole. This could be considered for a dowel hole. You could do screw clearances. You can do a lot of different types of hole there. And let's see, this wants me to select, I'll just do nominal. And then for positions, I'm going to select this face, and I'm going to draw 2 holes on it. Now, the top part is 3/4 of an inch wide, well, 3/4 of an inch thick, and my screws themselves are 2.5 inches. So 3/4 minus 2.5. Basically what that says is oh, I should zoom in on this piece. I'm just drawing circles. Okay, so looking at this piece here, I've got 2 circles. I'm going to click out of my circle command. I am going to add some relations by selecting that circle, holding down Control, and selecting this circle. I'm going to make them be equal. And then what I'm going to do is I'm going to create a line, and this line is just going to be for construction purposes. And what it'll do is it'll go from here to here to establish kind of the top boundary. But then I'm also going to go from this midpoint down to this midpoint, down to this midpoint. And then I'll hit escape. Now I want this line to be vertical, I want that line to be vertical. So I'm going to click on that line, make it vertical, click on this line, it's a woo! That's already vertical. It's got a vertical to relation. And that's good. And then I drew this from the midpoint up here, so it is going to be center aligned here. Now I just have to give a couple of spacings. So I'll click Smart Dimension, and I'll dimension this construction line that I just drew. And let's see, I want this to be 1.5 inches in, and then I want, whoa. I feel like I was looking into the past right there. And then I want this to be 2 inches away. Maybe more. Let me zoom out and see where I'm at. Yeah, I might make that 3 inches. Okay, one last dimension that I have to put in here, and that is the diameter of this hole. So here, the diameter of the hole, as we drew the screw, is 0.1875 inches. So and enter. So kind of small screw holes. I'll hit yes on that. Now we're still in the hole position, so I'll hit yes. I'm satisfied with my 2 hole positions. And it says it doesn't like it, so I'm going to go over here and try to figure out what happened. Oh, did it really just delete my entire sketch? It totally did. Nice. You know what? I'm done with this. I don't want to play that game. That was stupid. That was a giant waste of time. We'll do this the old school way. Drawing a sketch, creating an extruded hole. So I'm going to do the exact same thing I just did. Thank you so much. First of all, I'm going to make sure what I'm looking at right here is I want to be drawing here on the top plane because I'm drawing the screws that connect down. So I'm just going to hover over top plane, see where that's at. Yep, we're good. I'm going to set this as for construction. I'm going to pan up and then shift my view. Pan up again. And then I will draw here to this corner. And then from this center line down and then down again. And escape. So I'll put 2 circles. SolidWorks is so slow. There we go. And escape. Now I'll select both circles, Control click on the second circle, and what that'll do is it'll allow me to add relations to both of the circles. I'll make them equal. We'll hit OK, and I'll throw in my 3 dimensions. So here this will always be in the center of this bracket. I want this dimension here to be 1.5 inches, and the other one to be 3 inches. I feel like I've already done this before. It's because I have. Boy, my computer's struggling. So we'll set this at 3. And then I'll dimension the circle itself. And it will be 3/16 of an inch. 0.1875. Alright, and then that's a fully dimensioned feature. I'll go ahead and hit exit sketch. Now here, as I said earlier, there's a 3/4 inch piece on top of this. So we're not going to need to go the full 2.5 inches. We'll go 1 3/4 inches. So I'll go into features. We'll do an extruded cut. I could probably go back and do a whole wizard with the holes I just drew. Well done, Kayla. Whatever. And I will make this go down a total of 1.75 inches. And then we'll go check and make sure that I didn't just drive out the bottom with that. Yep, we're good. We're still in the middle of the material there. So I'll say that's good. Nice. Now we have 2 of our holes. And what I will do is I'm going to drill through holes on this side. Now the nice piece about this bracket is because I just copied and pasted this bracket in twice, those through holes, I can connect screws on one side or I could connect screws on the other side. It's not going to matter. So my bracket design is going to be identical for both pieces. I'm going to do another sketch. I'm going to sketch on this face. I'm now in a sketch. You'll see that the sketch pops up in the lower corner, showing that's where I'm at. I will zoom to this face. And then I'm going to draw some construction lines again. As I like drawing construction lines, it makes things easier for me to understand that way. So first thing I'll do is I will draw a line that goes out this way and then down twice and escape. Now I'll put 2 screw holes at those 2 line points. And I will set those 2 equal to each other. So click on one, control click on the other. And set them to equal. Now I have 3 dimensions, I need it, well, 4 dimensions. How far in am I putting them? It'll be this line. I'll just drag that down. And let's say the whole material is about, well, that I'm screwing this into is 3/4 of an inch wide. So I want the center line of these holes to be at 3/8 of an inch. So it's going to be 0.375. That's 3/8 of an inch. Okay, now this distance down. The total distance that I have is 6 inches. So what I'll do is I'll kind of break it up into thirds. 6 inches divided by 2. Each of these is going to be 2 inches. Boy, SolidWorks does not like that I am editing this as I go. We still got a little bit more work to do too, because I got to go put the screw holes in to the top and the back brackets as well. And here it'll be 2 inches in, 3/4 of an inch wide. We just got to make sure that they line up. I'll set this as 2 again. And hit enter. And then I will dimension this hole at 0.1875. And enter. Exit sketch. Features, extruded cut. And here, what I'm going to do is, because I want these screws to go all the way through this material, we'll just do through all. You could do through all both too if you really wanted to. That'll make sure that it actually cuts through the material, but it's your world. And then I'll hit OK. So there we go. I got my screw holes in my bracket. I'm going to quickly save this. And I will go on to the next piece. So here, you can switch just by clicking on this. Oh yeah, that did not do what I wanted it to do. So I'm going to pick a different window. Let's see, we've got our assembly open, bracket open, screw open, back panel, top shelf. We'll start with top shelf. Switch back to top shelf. And then what we'll have to do is we'll have to drill holes on 2 sides. Now here, our piece, our back panel piece is 15 inches wide, and then we have 1.25 inch wide brackets. So what we really have is we have 16.25 inches from center to center for that bracket. So I'm going to need to draw holes 16.25 inches apart. So what I'll do is I will do a sketch, and then I'll do a mirror of that sketch of the holes, and just make sure that it's 16.25 or 8 and 1.25, 8 1/8 inches away from that the center line of this item. So I'm going to go ahead and draw on this sketch, face, zoom to that surface, draw a line. Here I am going to draw it for construction. We'll draw over, down, and down. Hit escape. Now I have my, this one is coincident, which is why it shows up as coincident, but otherwise I would want to make sure that it's horizontal. In fact, I will draw horizontal there just to make sure. And then I will draw my 2 screw holes. Similar to last time, I will select both circles. And I will set them to equal. and hit OK. Now I have 3 dimensions to put in. This one, well, 4 dimensions, including the diameter of that line. So here, this is half the distance between center to center of my 2 brackets. So it's going to be 8.125 inches. If I got my measurements wrong, it's going to show up when I go to assemble these. Then I can always go back and fix them, which will be nice. This was 1.5 inches. And this one here was 3 inches. And then I'll dimension one of the diameters of the circle. Set this to 0.1875, which is the diameter of our screw. And enter. Now I've only got half of this drawing. I will have 2 other ones on the other side, but when I hit exit sketch, I'll do a mirror later. We'll mirror about, we'll probably have to create a plane in the center of this item, which would have been a lot easier. But we'll do that when we get there. Here, extruded cut, or you could do the whole wizard. I prefer the extruded cut because it doesn't work sometimes. It drives me nuts. And here, because we're going to be drilling all the way through, we'll just do a through all cut. And okay. And you'll notice a couple of holes pop up. They're tiny, but they do go through the entire material. See the shadow on the other side. But yeah, that's a through hole. Okay, now I'm going to create a quick plane in the center of this object. So to do that, first reference is going to be this face. Make it parallel. Second reference is going to be center point right here. We'll make that coincident, and you'll notice it's fully defined. That is in the center of this object. So if we made this bigger, we could always make it bigger. We could change dimensions, but that plane will always be in the middle. And then what I'll do is I will do a mirror. So with this face, this plane, that plane is going to be my mirror plane. And the features to mirror are going to be this cut extrude. So you'll notice that they pop up over there, and I hit OK. I'll go ahead and save this quick. And now I have to do some hole drilling on the back panel. So I'll switch to that part real quick. And when we go to assemble these will assemble very quickly because I've already got the holes aligned. Hole alignment in SolidWorks is really, really simple. So here's my back panel. Now, once again, I am going to do a mirror. So it'll mirror this feature about the center line of this. So what we'll do is we'll do a sketch. I'll do it on this face. We'll do a sketch. I've already got that face selected. Now here, this back panel, the way that it was oriented was we put 2 holes 2 inches apart, pretty equally spaced throughout this. So what I am going to do is I'm going to do what I did last time and draw my construction lines, use my construction lines to identify the location of my holes. But I am going to draw it from the top up here because that's where my dimensions are on my bracket. There's one, measure from the center line, down, and down. And then I'll draw two circles. And then I will click on both of the circles. Allow me to add relations. Make sure that both circles are selected, which they are. And then I hit equal, so they're equal radius. Now I have 3 dimensions to put in. This distance here is 2 inches. I'll set this as 2. And then I will set this line at 2. And take my circle, give it a dimension. This is 0.1875. Okay. Now our brackets are 1.25 inches wide. Our screws are 2.5 inches wide, which means when we drill these holes, they're going to be 1.25 inches wide. It's simple maths. Bop, bop. So I'll go in and do an extruded cut for 1.25 inches for both of these. Hit yes, and then what we'll do is we'll mirror this about the center line of this feature. Alright, so first of all we'll start by doing our reference geometry. I'm going to make it parallel to this face and select the midpoint up here to make it fully defined. Scoot back over so I can see my holes. And then I will set a mirror function. And I've already got the plane selected, so the features to mirror, I'm going to go in and select Cut Extrude 1. And you'll see it shows up over there. And I hit OK. So now I've got all of my connection holes of how I'm going to screw this thing together. I'll go ahead and File, Save. And go back into my assembly. Now what you'll see, the moment we go back into this assembly, SolidWorks is going to freak out a little bit. Because SolidWorks says, whoa, your parts have changed since the last time I looked at this assembly. But then it'll go in and it will actually put in all of the holes that I just created that sort of way. Now you'll notice I forced this face to mate here, but it really, like, it kind of screws things up because I can slide it way off into the distance. It's really easy to screw things up with just a face mate like that. Now, what I will do is I'm going to drag this out here quickly. This is my back panel. I'm going to start by aligning these panels here. So first thing I'm going to do is I'm going to mate this so that they're stuck to the bottom of this top plate. So I'll delete the face that I currently have selected. Select this face and put it on here. I'll hit yes to make that mate, and then I will pan over and do it for this face over here. So select the bottom side again, select the top of this face so that they are mated together, and then I'll hit OK. Now I want to mate the center lines of these holes together so that that's how they're oriented. But in order to do that, I have to do something very special. I have to go into View, Hide Show, and this gives me options that I can look at. Now here, if you have axes that you've drawn into any of the parts, planes that you've put in to any of the parts, you can actually take those and mate them to each other, which is really nice. For me, temporary axes are formed every time you extrude a circle, because it goes along the length of the center line of the circle. It's basically an extrusion of the center point of that circle. So if I enable the temporary axes, you will actually see that there are now axes that define the center line of each of these holes. So if I just go and pick those axes like that, and I set them to coincident, it will line those up. And I'll hit yes. And I'll do the same for this axis and this axis. Make them coincident and say yes. Now, if my dimensions here were off, I wouldn't be able to do that. I would have to go fix it. But that's a great thing. SolidWorks will let you know if you have hole dimensions that are at different places in your assembly. So if I went back and edited one, but I didn't edit the other, SolidWorks would give me a giant error message. Things would blow up, like World War III, but just in SolidWorks. So now that I have, whoa. What are you doing? Now that I've mated all four of those, the last piece is I have to mate these pieces here. Now you'll notice I don't actually have to mate all of them. It would actually over-constrain the drawing if I did. So I'm only going to mate really one. Because I set that, well, no, I'm going to mate just one of the holes. But now when I click out of this, if I grab onto this and I drag it, I can move it this direction. I can't move it anywhere else, but I can slide it in and out. So I'm going to mate this face here to this face here. I could also mate the center planes that I created if I really wanted to, because I created both of those center planes. But now here is my shelf bracket that I have made. The last piece is I have all the holes for the connections. I'm just going to drop screws in there. So we're going to need 1, 2, 3, 4, 5, 6, 7, 8. Now the nice piece about doing it this way is when you build your assemblies like this and you put in all the pieces, including the screws, you can copy and paste very nicely. You can get good part numbers. It's just everything is better here. So here I've got a screw. I need 8 of them. I think you can copy with mates. So if you want to, if you put 1 and you mate, so here if I make this one, let's say I'm going to mate it. Now here I put a beveled edge on this, so it's not going to sit perfectly nicely in. If I would have just made it a flat screw or put in a chamfer on my holes, that would have made this a lot nicer. I didn't want to do that because I was trying to go for simplicity here. So I'm just going to mate the top chamfered circle to that hole. And hey, yeah. So basically all I did is let me undo what I just did. That's a dumb way of doing it. I'm going to start by aligning this piece here to this hole here. Okay. And then what I'll do is I'm going to select the bottom chamfer circle here, this circle at the base of this screw. This is the one that I want to be in line with the top face. I could also just select, you know what, I'll just select the top face. I'll force this screw to go in. So here I'll click mate. I've already got that face selected. And then I'll just shove this screw into this top surface. The idea is that the wood will move. Or I will make you. Good design, I would chamfer those holes in the surface so that I don't have to make the wood move. But like I said, I'm not designing this well. I'm just designing it. Now sometimes you may run into the issue where it flips the screw over. So here my screw is shoved into the hole, but it may flip it over. You can actually flip the direction of the mate so that if it is flipped accidentally, you can flip it back over. So now what I'm going to do is I'm going to click on this piece and I'm going to copy it with mates, which is going to put 4 screws on top of each other. I'm going to have to go back and delete one of them, one of the mates, which will allow me to mate it to the other one. So here, copy with mates. There's my screw. I don't want to select the top shelf. Nope. Nope. Never mind. Should be able to copy this. Now this does have a minus sign on it. The minus sign means it's not fully defined. But realistically it isn't fully defined because I can spin that screw in that hole without changing anything. Now I'm just going to add screw. And then add another screw. And then add another screw. And I'll turn around its side and I'll add more screws. And then we'll mate them the same way. Top of the screw head to the front panel top. And then the screw axis with the screw hole axis. And we'll do that for all 8 screws, and it will take a little bit. And then what we'll do is we'll just throw this assembly into a drawing, save the drawing in the same folder. And what I will encourage you right now to keep in mind, we are going to be using this same drawing next week for our modeling learning assignment. So next week you won't have to redraw this entire assembly. We're going to go from where we already have. So click on this axis, hit mate. Just to go in there, hit yes. click on the top face of the screw, click on the surface, force those to mate. Okay, zoom back, pan over, select this axis, select this axis, yes. Well, I'll just move this axis while we're at it. Hit yes. Zoom in. Select this face. Select this face. Yes. Select this face. Select this face. Yes. So now I've got all 4 of my screws positioned. Now putting each one of those components in together wasn't fun. So I'm going to go insert components. And what I will do is this says use the push pin to insert multiple copies of the same or different components. So here, I think if I just push the push pin, I can put one down here, one over here, come on, SolidWorks, one over here, and one over here. And then I'll hit OK. And I've got all 4 of my components in. And now it's just time to jump in there and mate them. You know, like I'm breeding animals. I'm going to save this quick because I have this feeling that SolidWorks is actually going to explode on my computer. Always rebuild and save. What it'll do is it will rebuild the definitions of each of the parts according to the most recent definitions of the parts that are saved in the files in the same folder. And then I'll just save this as MLA 3 shelf assemb. Alright, now it's time to throw in the mates real quick. Click on mate. Thankfully, I think the mates go pretty quickly. Orient my view so that I can see the hole in the surface. Start by clicking the axis here, aligning the axis. Hit OK. Now that was actually backwards. So I will need to reorient this because when I mate these two together, the screw will appear to be sticking out of the face of the shelf. So here, this handy dandy little pop-up here has the flip mate alignment. Down here, you can also flip the mate alignment here. Both of those do the same thing. Basically, it just flips it in and out. And then I hit OK. We'll have to do the same thing for the next screw. So here, select this axis, select that axis, it'll orient it. I can just flip it around right now. Doesn't cause any problems. It's OK. Select the face of the screw, select the body of this. There we go. Don't know why it was struggling with that. And hit OK. So now you'll notice that both of those screws are there. I'm going to go ahead and quick change my orientation around to the other side. Orient this axis to this axis. Hit OK. Select this screw head. Select this face. Hit OK. Select this axis. Select this axis. Make sure that the axes are actually selected. Hit OK. Select this face. Select this face. Hit OK. And now I'm done with my assembly. I have all of the screws in. I know that's kind of an arduous process to even put the screws in. Putting in screws does add a lot of work to a drawing, as you can tell. But it's going to allow us to do some pretty cool stuff when we do some work with this in the next video. We're going to be doing some dimensioning, working with an assembly in SolidWorks. So I'll show you some of that in the next modeling and learning assignment. To finish this modeling and learning assignment, let's just throw this in a drawing. So we're going to do our standard 3 views with the isometric view. We'll shade the isometric view. We'll fill out the bottom title block, and we'll call it a day. So here I will first start by browsing and going and finding that template that I've been using. So desktop. There we go. That'll show up here. I'll hit OK. First thing it's going to want to do is it's going to say which model do you want to insert. And we're actually just going to put in the assembly. So start with U, double click on that, put it in here. We'll start with a front view, then we'll do a top view. And then it'll do a side view. And then we'll do a projected view. All right, and then we'll hit OK. Now I like to move my projected view down a little bit. You need to move these over. We have space. There's projected view. As much fun as this orientation of the view is, it's just like the top view is just slightly rotated. I'm going to pick a different one. So I'll click on this view specifically. Whoa. And what I'm going to do is, oh, that's not going to allow me to change that view. Oh well. But we will set that as shaded. We'll call it good. We'll fill this out and produce a PDF of this drawing. So here's the name of the drawing. This is going to be shelf. Description of the drawing. This is shelf assembly. MLA 3. And it is in inches. So go ahead and say we're done with this. Last step, go to properties, author CJS. And there we go. We'll save this. It will want to update the definition of the assembly drawing, which will simultaneously update all of the parts in that assembly, which may take a little bit for it to work on. Then I will just call this MLA 3 shelf assembly. We'll export this to PDF, and you'll hand in that PDF just as we've done before. All right, it's kind of a longer MLA assignment. Next week shouldn't be as long, but will involve a lot of editing, going back in, modifying parts, that kind of thing. So, and doing